we have, today is 20. Okay, so today class is done. We have 27th of January, 3rd of February, and 10th of February. This one is 10th of February will be Chinese New Year. Okay, so we want to use this class, okay, to replace it on other day. Okay, so since this on 20th of January, okay, is today, so we haven't decided yet because we thought that we have replaced the class last week, right? Okay, so we only have these 2 dates, okay, to decide our replacement class. Okay, during the replacement class, okay, I will do the, I think better we do in the evening, right? We can do the midterm. Okay, so during the replacement class, I will do the midterm. I will do the midterm. Okay, so however, on 10th of February, okay, on 10th of February, it's Chinese New Year, right? How long is Chinese New Year? Until 11 or 10? Sorry, until 11 or 12? Let me check. Oh, Saturday, right? Okay, Saturday. So, okay, I think, okay, on 10, Saturday, 10. Okay, so on 12th of February, oh, sorry. Okay, on 12th of February, I will release your final assessment. Okay, I'm not sure how I'm going to do it, but I think I want to do some analysis, essay, okay, and maybe some online quiz. Yeah, okay. I don't want to do the video anymore because this time I was like, last time it was very like time consuming to watch your video. So this time I think I want to do the final assessment. So I will release on 12th of February. So you'll be given 7 days to do it. So perhaps by 19th of, okay, thank you, host. Wait, let me check. On 27 January evening. Okay, so the only choice is only 3rd of February. Is it okay? Okay, 3rd of February. Quite like. Okay, since the midterm has been dragged to 3rd of February, okay, since midterm will be 3rd of February, okay, evening. So, but I will confirm with you again the time because I have to check the slot with the Uniraza. Okay, I will check the slot with Uniraza. It's 3rd of February evening. Okay, but the time is not confirmed yet. Okay, the time is not confirmed yet. Okay, so for your midterm, it will be online invigilation, exam invigilation online. So I will invigilate just, okay, via online. Okay, and you have to turn on your camera. Okay, make sure you have stable Wi-Fi. Okay, you make sure that you mute yourself, but turn on your camera. Okay, I will invigilate it. And on 12th of February, okay, 12th of February, like maybe like a week like that, I will release final assessment and you have 7 days to do it. So the deadline of final assessment will be 19th of February or wait, let me check. 19 will be the deadline. Okay, so if you have any request, will be 20 or 19 or 20 deadline. But I have to confirm with Uniraza first because they have like specific timeline. Okay, so I have to follow that. Okay, since my the semester, okay, in my current university has finished. So I'm very free. After Tuesday, I'll be very free. So I'm going to like I'm going to mark all of your assessment and return to all of you. Okay, so I'm not that busy anymore. So I have like the thing that I like my current university is when we have like some semester break, we don't have to go to work. So I have like 2 months break. 2 months career break, okay, before I begin my semester on April. Okay. No. Replacement class on 3rd of this one. 3rd of October. Sorry, 3rd of February. 3rd of February. Okay. Can you confirm with me? Oh, you have research methodology on 27 evening.
I got presentation, I think, but I need to
Presentation
confirm
on
later.
3rd or 4th.
Yeah, there will be 2 days of presentation because there are 100 students.
Oh, I
Mm.
see. So when we should do 27 evening, you have a midterm for research methodology. Third, you will have a presentation before evening, 3rd and 4th. Okay, how about 28th? 28th of January, next week. Yeah, evening. No, I don't care. It's Sunday. Okay. Sunday for class. Oh yeah, I forgot. Hmm. So what should I do? Actually, I was kind of like pissed off because of the last week because we have like arranged the schedule. Okay, and I tried to email, contact everyone. No one pick up the phone. It's not reachable. Okay, and it's not. You know, I expect your time, and I hope that others will do it the same to me. So, but the thing is, okay, they did not like. Um, I tried to contact everyone, but no one replied my email. Okay, until Wednesday. Okay, they contact me. She said that when you are going to do my replacement, I said that I can't do because I haven't discussed with all of you. Other tools, yeah, I prefer to use Teams to be honest. But the thing is, SKC wants to host the yeah, I use Teams. Okay, I use Teams and Skype, but Google and also Google Meet. But the thing is, SKC will be the one who take your attendance and all that. But I will try to contact them by Monday. Okay, I will try to contact them by Monday. Okay, because I'm free and after Tuesday next week, I'll be free as a bird. Okay, so yeah, I can do on weekdays too at night. But let me confirm back with SKC if it's allowed or not, because they are the one who going to take the attendance. It's not me. Okay. Okay. Okay, let me confirm that and we're going to discuss it. Okay, I will try to do the like some kind of forum in the Europe, so you can like vote or comment in that, okay, about the replacement class. If I use different tools, not Zoom, okay, we use other different tools. Okay, thank you. Okay, so your midterm, okay, so you cannot do the, so your midterm is, okay. So let's see how we are going to slot in the replacement class. Okay, so let's look at our third chapter, okay, which is okay, data processing. Okay, data processing. Okay, data mining has grown to be a core process that leads to success. Okay, it's because it helps us to analyze and discover the patterns in data that help the business leader make the proper decision. Okay, so decision come out from our analysis in data mining. Okay, and some before that, okay, before we're going to do the analysis, okay, we have to deal with the data extraction. Okay, it's a critical process. Okay, because it ensures that the business has substantial business data. Okay, so we have to know, okay, how much data that we need to get to run a proper analysis. Okay, like if you want to use regression, okay, so if you want to use regression, your data must be normal. Okay, if you want to use regression, your data must be normal. Data is normally distributed. Okay, usually by using central limit theorem. Okay, this is statistic. I just want you to know. Okay, when your data is approximately normal, okay, your observation must be greater or equal to 30. So your data must be greater or equal to 30. Okay, the bigger, the better. Okay, so if you want to see whether you have a substantial business data or not, it must be more than 30. Okay, the type of data, mode of data collection, and the source of the data collected are some of the important aspects that a business organization has to consider during the data extraction. Okay, so let's say you want to do a smart like sales and marketing analysis. Okay, sales and marketing analysis. Okay, first I have to make sure that my data must be greater than 30. Okay, so we have to also, what is the type of data, mode of data collection, and the source of data collected. Okay, so what type of data is it? Okay, so maybe you want to collect, okay, the sales for the past 10 years. It cannot past 10 years, maybe only 5 years. Okay, you also want, so you know that for the past 5 years, your data will be in numerical value. That's a numerical value, and it is a continuous types of data. Continuous type. Okay, and other than that, okay, this is a sales and marketing. Okay, maybe you want to see that like the product type. Okay, what types of product? Okay, whether it is okay food. Okay, sales and marketing in a convenience store. Let's say convenience store. Okay, so maybe you want to find a food. Okay, whether it is like food and beverage. Okay, whether the product is come from usually convenience stores. Okay, but have like hygiene product. Okay, maybe the product is for like tobacco product. Okay, so we know that the type of this data is okay nominal type. Okay, nominal types of data. And other than that is maybe you want to find the sales product. Okay, what you want to see. Okay, what is the okay you want to see whether what is the satisfaction. Okay, customer satisfaction. Okay, very satisfied. Okay, I'm satisfied or just neutral. Okay, so this one is type is ordinal. Okay, so this is like example of okay, if you want to do okay analysis of sales and marketing in a convenience store. Okay, mode of data collection. Okay, so all of the mode of data collection here. Okay, because I use a data warehouse, so I got it from the data warehouse. Okay, from sales, we have sales record. Okay, for product also we have a sales record. And customer satisfaction, usually we will get it from the, okay, usually when you buy something, okay, what is your level of some customer satisfaction? You can just click it on the monitor. Okay, so everything is already in the data warehouse. Okay, so solve the data collection also from the data warehouse. Okay, so mode of data collection is coming from the store itself. Okay, so of course you are a convenience store, you are Speedmart, so you want to compare with Mart, you want to compare with 7-Eleven, okay, which is have 24 hours services, and you also want to compare like with a small convenience store, okay, with a small convenience store. Okay, and if the business organization either collect the wrong data, collect data using wrong mode, or collect data from the wrong source, then the business success is at stake. Okay, so for like small or medium enterprise, okay, usually if you make a wrong decision, okay, it causes a stake. It causes like a risk. Okay, the need for data pre-processing takes place during the stage, and data pre-processing is important for a business organization to ensure that they extract relevant data in the right way to ensure proper decisions are made. Okay, so before we have all these types of data, we have to pre-process it. Okay, before we begin with analysis, we have to prepare the data, make the data ready before we can proceed with data mining analysis. Okay, recall back what is data mining analysis. Okay, you can do like classification, you can do association, regression, what else? Okay, you can do sequence analysis, sequence. Okay, you can do time series and forecasting. Okay, and you can also do outliers, okay, and so on. Okay, so this is like analysis or like task in data mining. Okay, so data pre-processing. Okay, data pre-processing can be defined as a technique of data mining that is used to change and transform the raw data from different sources to a more efficient and useful data format that can be used by the business organization for analysis. Okay, so you have to ensure that the data is okay neat enough to do the before it can be processed. Okay, so if you have any issue in the data and you not handle it well, okay, it will lead to faulty output, okay, which in turn may lead to the wrong result and assumption. Okay, so what is it? Okay, so we have few issues, okay, for the data pre-processing. Okay, we have to look at the data quality. Okay, we have to look at the data quality. Okay, so what is the data quality? Okay, so we want to see, okay, how to fit data quality can be defined as the standard of how to fit the data is to be used by an organization for decision making and intended operation. Okay, so whether if you have like 1,000 of data, if your data is not quality, oh, sorry. Yeah, we have quiz today. We have quiz, short answer quiz. Oh, I forgot. Okay, your short answer quiz. Okay, we begin 11 until 11:30. Okay, actually I want to do longer, but I just did it this morning. So yeah. Okay, it only has, wait, let me see. It carries 30 points. Yeah, it has 30 points. Okay. So it has 8 questions. First question is matching. Second question, fill in the blanks. Third question, fill in the blank. Four, five, six question, true, false, and last one is like classification. Classification question. Okay, you only have 30 minutes to do it because it's short answer. Okay, so yeah. Okay, you will do it around 11 until 11:30. Yeah, I thought I want to do like 10:30 until 11. But okay, let's see how I can edit it at any time. Okay, I can see. Okay, we see how our when our class will finish. Yes. Okay. So yeah. Okay, you just have to match. It's my first time using Europe. Okay, to play around with the quiz. 30 minutes. Yeah. Can. Okay, you just have to match. You just have to choose. You just have to choose. The answer is there. You just have to choose. Okay, fill in the blank, but I provide you the drop-down list. Okay, you just have to choose. Of course, I put a distractor. Okay, so you have to choose which answer for which question. Okay, and also there's a wrong answer and also some just distracted question. Okay, you just have to choose. Okay, and yeah, okay, you can okay, you can do it in 30 minutes, I think. I put 1 hour, but no, because I wish that I want to do it like more, but I don't have time because I just did it this morning. Okay, yesterday I ended my meeting quite late. Okay, and after this, after Tuesday, I will have like 2 months break. Okay, in my current university, if you during the semester break, we don't have to go to office. Okay, and in fact, now also I don't have to go to office. We only come for the meeting and also for the class. Yeah, it's quite like, and my boss and all of my colleagues are mostly are expat. So usually during the semester break, they are having like when they are having holiday. Even my boss in Austria. So after the meeting, he will fly back to his hometown, and he will return back when the semester begin. So everyone is flying to US, to everywhere. Okay, so yeah, so they are very private, and during the holiday they will not disturb you at all. So that's the yeah, that's the best thing about my workplace. Okay, so back to the data quality. Okay, quality data should be able to fit the following. So you have to be unique, consistent, accurate, comparability, and completeness. Okay, data pre-processing ensures that the raw data collect is able to exhibit these qualities before it can be used to conduct data analysis. Okay, for data pre-processing to be used, okay, raw data must have some particular problem that might make it to be error prone. Okay, so we have three major problems with raw data. First is inconsistency. Okay, missing data and also noisy data. Okay, data inconsistency. Okay, so let's say the data files with similar data stored in different format. Okay, usually leads to inconsistency of data. Okay, let's say I save my data in Excel. Okay, but I want to use it in, let's say, SPSS. Okay, so when I convert Excel to SPSS, okay, Excel, okay, maybe in Excel. Okay, so I want to convert into SPSS, so I have to okay, change it into CSV. So when I convert it, some of the format, okay, is altered. Okay, so it is altered, so which means that okay, which I check with SPSS, okay, some of the data is, some data is distorted, so we have to correct it. Okay, so sometimes, okay, when you use, let's say I use my column in my data, as maybe I use my column is one class, two class. Okay, so when I convert into CSV and export it into SPSS, okay, SPSS not allow number, okay, now it can handle that, but it used to not have, they cannot handle this one, the number of the column as will begin with number. So they automatically, okay, we change it, become, okay, this one class, right? So they will change it into underscore class, something like this. Okay, and it has changed the entire, okay? So, so it has changed in the code of name, and data constraint has to found be absent. Okay, there will be inconsistencies of data. Okay, let's say class. I put class A until B. Sorry, A until F. So the class will be A, B, C. So maybe F, G, F. Okay, I, E. Okay, so you see that my class is until A until F, but I found, okay, these two class H and I actually, okay, is, okay, my constraint is only until A until F, but now I have H and I. Okay, so this H and I, okay, is not related to my class in my class data. Okay, so which means that, okay, is the data has been violated. It provide the inconsistency, and this is the data inconsistency. Okay, sometimes, okay, let's say I put like maybe the another column data is unique. Okay, column data is unique, so unique should be in number, right? Okay, maybe 1 until 100. Okay, so unique would be 1, 2, 3, 4, 5, and this one 99 something. Okay, but it must be integer because unit is like, okay, unit must be integer. It must be a round number. Okay, somehow I found a data that used 3.5, 2.75. Okay, so you see here, okay, these two data is inconsistent. Okay, two, okay, it's inconsistent and affect my data quality. Okay, so we have a few methods, okay, how to avoid with the data inconsistencies. Okay, we'll talk about it after this. Okay, other than that, we are also dealing with missing data. Okay, so when there are gaps in the data being extracted, then the data will be inaccurate for analysis. Okay, so missing data means, okay, the data, okay, let's say I have another column, okay, class, unit, another one maybe type. Okay, what type is it? 1A, 2A, 3B, 4C, and so on. Okay, so I have like 3 and missing data. Then after that, it will be 1A. Okay, so all this missing data, if your data is big, okay, it doesn't affect much. But if your data is small, missing data can lead to a wrong conclusion, wrong decision. Okay, so when there are mistakes made during entry of data, okay, there is a system fault or problem that might occur during extraction phase of data mining. Okay, nowadays, okay, the system will detect if there's any missing data and alert us. Okay, and alert us. So which means that the analysis will still going on, but okay, the missing data okay will give like different like wrong output. Okay, some of the analysis that if you have like missing data, the analysis can't even proceed. Okay, so you have to do the fixing process, okay, the pre-processing data before we begin with any analysis. Okay, the third issue that we're having when you compile the data is noisy data. Okay, what is noisy data? Okay, data can be referred to noisy if it contain outliers that render the data meaningless. Okay, so let's say that, okay, you have a unit 1 until 100. Okay, suddenly out of nowhere, okay, you have a data that is -1, then negative 100. Okay, so this is outliers, is inconsistent, and also it is outlier. So it is far from your from the okay unit that you specify. Okay, so you have to do something, okay, to this to remove, not just to remove. Okay, we're going to learn after this to avoid the noisy data. Okay, noisy data, okay, usually will distort your outcome of your analysis. Okay, so it is so far missing data, inconsistency data does not affect much, okay, if your data is big. But noisy data, yes. Okay, if your data is big, but having a noisy data, okay, will change the conclusion in total. Okay. Okay, another types of missing data is maybe because you mislabeling of data, human errors, okay, or anything, okay, during the data gathering. Okay, what we have to do when you have a issue with your data? Okay, so we have many like as a statistician, okay, we have many ways. There's no specific ways to overcome the issues in data. Okay, so some of it we use transform from the raw data to the user data. Okay, we can do like transformation. We can delete it. We can just ignore it, or we can put dummy variable. Okay, to dummy variable to represent the issues in data. Okay, or we can, there's many other tools that we can use to fix, okay, for your data inconsistency. Okay, so the first one is we use the data cleaning. Okay, so this task involve finding missing value in data and filling them. Okay, or do you remove the noisy data? Okay, so to make sure that data is consistent. Okay, so if you see that any missing data, let's say here, we have here missing data, so we just remove the entire column. So remove all these 3 columns. Okay, so but it is doable if your data is a lot. Let's say if you have like 100,000 of data. So by removing only 3 data, okay, it will not affect much, right? Okay, it will not affect much. But if your data is like around 100 something, so when you remove 3, okay, it will change the conclusion. Okay, and after other than that, is you find the missing value, then filling them. Okay, let's say you find a missing value. Okay, so you know what value that it should be in. So you fill it up. Okay, so maybe I know that this is the value of, okay, 7 and 9. So I fill it up. Then I can run my analysis. Okay, another is noisy data removal. Okay, let's say here you have found these two outliers, right? Okay, you have found these two outliers. So, okay, you know that this data is not important and you don't know what value you're going to fill it up. So we just remove it. Okay, you remove the whole row. Okay, like I said, if the data is big, okay, it will not affect much. But if the data is small, okay, you have to find a way how to fix this issue. Okay, next is data integration. Okay, so another method. Okay, what is data integration? Okay, this is the task that ensure that the data from different sources brought together. Okay, so which means that if you use, I think if you use SQL, there's no problem with it because there's no duplication and there's no the data will be in good quality. Okay, so the integration, okay, from one software to another software must be accurate. Okay, so in order for you, okay, to find that the data is in a good quality, okay, make sure that you okay, the SQL is good, okay, because there's no duplication and all. Okay, make sure that when you do from different sources, okay, the format match, okay, the format match and the standard is made, okay, so that the integration should not be any issue. Okay, and data transformation. Okay, so that this is a data pre-processing that ensures that the aggregation and normalization of data is conducted per datasheet need. Okay, so usually, sometimes, okay, when you want to do analysis, let's say regression, okay, if you see here, okay, I give you another example. Okay, let's say you want to find like the data, like what is the house price, okay, versus the salary. Okay, so you collect house price and also you collect the salary of the worker, right? Okay, so the house price here, okay, can be like 5 million, okay, 500,000, 200,000. Okay, this is a monthly salary. Okay, it's a monthly salary. So monthly salary maybe 7,000, 5,000, maybe like 1,500, the minimum in Malaysia, and so on. Okay, so in order for you to do the regression, somehow, okay, this unit is a bit far, right? The monthly salary. Okay, so we transform the monthly salary, okay, into annual. So you times by 12. Okay, so you make it the annual salary. Okay, to make it like the house price, when you do the regression, okay, it's easy for you to read the output. Okay, it's easy for you to read the output. Okay, let's say it will be y is equal to like 0.5 minus 1.65, something like this, the output of regression. Okay, if let's say you don't change the value, okay, your output will be somehow like y equal to 0.00005, okay, minus, okay, 0.0016x. So it's different. Okay, the output will be this one is easy for hard for you to find the conclusion. Okay, so some other causes is if your data is too big. Okay, let's say this one, you see that the data is very big, right? So you transform the data into a different variable. Okay, so I use natural logarithm and I log the house price. Okay, so I log I use the calculator, log 5 million, you get the value. Log natural log 500,000, I got the value. Natural log 200,000, I got the value. Okay, so this is another way for you to transform. Okay, some of the transformation, I found it. Okay, we use the reciprocal. Okay, we use the reciprocal. Let's say I want to calculate the bacteria data, right? The bacteria data in a water. In a water. Okay, so bacteria is very small. So it will be like micro or nano units, okay, per liter. Micro per liter. Okay, so it will be like 0.0005, 0.0001. Okay, this one, okay, is very hard for you to do the analysis. So you use the reciprocal. Okay, so you change to another variable. Okay, you put 1 over 0.005, so you get the value. 1 over 0.0001, you get the value. Okay, so that's many transformation that you can do, okay, in your data, okay, to help you with the analysis. Okay, other than that is data reduction. Okay, data reduction in the data processing task, the number of data records and attributes is reduced with the data's result, with the original data's result. Okay, so if you want to like carry out analysis using data mining, okay, if you did the data, I prefer big data to be honest. Okay, but somehow if the data is too big, okay, if the data is too big, it's not necessary for you, okay, carry out all of the data. Okay, so we reduce the data dimension. Okay, so how to reduce the data dimension? Okay, if we want to do an analysis, house price versus salary, okay, and you have many data, okay, you don't have to select all of the variable. Okay, maybe the variable that is suitable for you to carry out is only the variable that is only, okay, if you want to do house price versus monthly salary, so it will be maybe house price. Okay, so this is, let's say, you have house price, okay, salary, size of the house, okay, and number of household, okay, cost, number of household, maybe you find the okay, cost of expenditure, cost of, oh no need. Okay, number of household. So maybe you want to find like this one, car type. What's another health level. Okay, so you want to do house price versus salary. Okay, some of the variable is not suitable for you to include in your analysis. So you reduce it by data reduction, means you reduce it. So the car type health level is unnecessary. Okay, so this one, which means that this is the only variable that is required by this analysis, which is house price, salary, okay, size of the house, and also number of household. Okay, so another one that is like a COVID, okay, COVID research. Okay, I want to do a research about COVID, okay, in 2022, until 2022, let's say. Okay, so the data is there with the KKM. It will be a lot, right? Okay, but I don't want to use the whole data. Okay, so I use sampling technique. Okay, this is statistic. Okay. I use sampling technique, okay, to find how many sample that is required, okay, for my COVID analysis, okay, to carry out the research. Okay, so I don't have to use all population. Instead, I only use sample. So maybe, okay, I only need like around 10,000 samples. So I select Okay, from Sarawak, because it's big, okay, so I use also sampling technique again. Okay, you only require from Sarawak is around maybe 3,000, 4,000. So I get 4,000 from Sarawak. Okay, from Sabah, how much? I select some. Okay, this one, I select some, select some. Okay, so I randomly select, okay, in mix of, okay, whether it is fatal or whether it is like survive case or fatal case. So I just random select it. Okay, and okay, so that one is comes some we can just remove the variable, or we can just use sampling technique. Okay, and because in statistical analysis, we don't have to know everything. Okay, we don't have to look at the all of the population. It's sufficient if you use only sample. Okay, last one technique for the poor data quality is data discretization. Okay, so it involves the replacement of numerical attributes with nominal attributes. Okay, so here we have this, okay, numerical attribute with nominal attribute. Okay, so we change all this. Let's say we have a missing data. Okay, so some of the data, okay, we just put null or not available. Okay, with nominal attribute. Or sometimes, okay, we create another dummy variable. Okay, we create any next is a dummy variable to, okay, replace the missing data here. Okay, but usually, okay, statistician not favor this data discretization. Okay, because we prefer that, because it will lead, this one is numeric. Okay, when we put is in nominal attribute, okay, is it the same thing? Okay, the analysis with your the software, we just ignore this part, because first, it is not in the right domain. Okay, it's not in the right domain. And second, it is not consistent. So we just ignore it. Okay, rather than you spend time to do all the nominal attributes, okay, we just delete it. Okay, or we create another dummy variable to represent the missing or inconsistency data. Okay, data pre-processing is used in the rule-based application. Okay, what we use in neural networks or the database application. Okay, I wish that we have like software to show you what is neural network. Okay, so it is critical in machine learning process to ensure that the data set is encoded in such a way that it can be passed and interpreted by the algorithm. Okay, usually we use neural network. Okay, not just neural network, other analysis also. Okay, any question? No. Okay, so I proceed with 3.2. Okay. Okay, data cleaning is the process of detecting errors, okay, on the data and removing them together with other inconsistency in the data so that the data can be presented with improved quality. Okay, so you find errors, remove them, then you proceed with the analysis. Okay, so sometimes we call it scrubbing. Okay, so problems in data quality are brought about by mistake during the entry of data, missing data values, or the presence of invalid data. Okay, so what you call is data is not clean, okay, dirty data makes the result to be inaccurate and incorrect. Okay, so reason to make the data to be unclean is, okay, you have problem in integrating the data. Okay, when you change the format, okay, when you switch from this software to another software, so you have problem with it. Okay, presence of dummy values in the data. Okay, like you should be in numerical values, but instead of it, you put it in a nominal figure. Okay, and business rules violation. Okay, so which means that some of the data are sensitive. Okay, these are sensitive, and it is not for you to, yeah, business rule violation is, okay, that is very subjective. It is very subjective. Okay, repetitive use of primary keys. So we know that, okay, primary keys must be unique. Okay, cannot be repeated. Okay, so if you repeat it, the primary keys, which means that there's a duplication in your data, okay, and your data is, okay, having issue. And you also have a contradiction of data values. Okay, what is contradiction data values? Okay, it means that if you have noisy data, inconsistency data, okay, so it's contradict with the data that you have. Okay, so we have three major steps that are taken during the data cleaning to ensure that the data is extracted, is clean, and ready for business analysis. Okay, first one, you have to handle the missing data. Okay, during the data mining process, okay, okay, there is no room for missing data. Okay, so when you want to conduct data cleaning, so you have to consider missing value. Okay, so to handle missing value, it depends on two factors. Okay, the first so there's a different ways to handle missing data. Okay, the first one is ignore the tuple. Okay, so which means that if the tuple is missing, so we just ignore it. Okay, like I ignore it, sorry. If, like I said, if you are working in a large data, okay, and you have a few missing values, you can just ignore it. Okay, so, but if your data is, okay, small, it's not big, okay, it is not advisable to ignore. Better to fill it up. Okay, better you have to fill it up. Okay, because if you not fill it up, it will give you a poor result. Okay, if you large data, it is fine. Okay. Okay. So if it is a small, if it is your data is not large, okay, you have to fill in the values manually. Okay, so when we check again and again using the summarization technique, okay, we know that once all of the value has been filled, okay, maybe like if you don't have any value, you can find what I did is, okay, if my data is small, okay, and I have missing value, okay, what I did is I find the median or the mean value of my data. Then I fill up the missing value using the mean and median. Okay, so how to fill in the values? Okay, usually for my case, I find the mean or median. Okay, look at the suitability of the data. Then I fill up, okay, using the mean and median value. Okay, I fill up using the mean and median value manually. Okay, if my data is not big. If my data is big, I just ignore it. Okay, so the use of global constants is also applicable to handle the missing data values if the missing values are not easy to predict. Okay, we use global constant. Okay, global constant, which is NA or 0, not available or 0, or sometimes we put there now. Okay, okay. Next is conducting mathematical analysis to come up with the missing values. Okay, so this one you see, okay, from the data that I have, okay, I conduct to find the average, mean or median. Okay, then I fill up using the mean or median or okay, mean or median values. Okay, that is how to do to clean the data. One of the way to clean the data. Okay, actually we have many statistical analysis. Okay, we have many statistical analysis that still can proceed. Okay, if you have a missing data. Let's say, okay, I have a population. Let's say I have a data for like house price. Okay, this one I have like around 50 observation. Okay, but salary, I only have 40, only 40 salaries. Okay, so it is not a balance, right? Okay, but in statistical analysis, okay, we have analysis to do, okay, with the unmatching data like this. Okay, So you can find out more. Okay. So handling noisy data and outliers. Okay, so to get clean data, you have to remove the noisy data and outliers. Okay, there's a few ways for you to do it. First, by binning, like removing. Okay, it's a technique that smoothens the set of data by dividing the set into similar size that will ensure individual handling of the data. Okay, so noisy data can be replaced through use the mean or use the definition of the values at the boundaries. Okay, so let's say you have outliers. Okay, so you smooth the set. Okay, so what is outliers? Outliers is like the value that is outside of your domain. Okay, let's say you have 1,000, 2,000, and suddenly you have 1 million. Okay, so 1 million here is your outliers. Okay, so you know that this data has issue, is not correct. So, okay, we use the mean, okay, or use other values. Okay, maybe you use the maximum values or minimum value or mode value or median value and replace it. So I come out, I want to use 5,000 as to replace the outliers. Okay, so I smooth it. Okay, I smooth it. Okay, other than that, we can also use regression. Okay, we can use the regression. This analytics technique conducts statistical process to conduct the estimation of the relationship between the data that is dependent, that which is independent. Linear regression can be conducted if only one of the data variables is independent. If there are two or more independent data variables, then the multiple regression is conducted. Okay, so if you have a noisy data, okay, you run a regression. Okay, to be honest, I don't run regression to find the noisy data. Usually, I just use scatter plot to find the, okay, what is scatter plot? Okay, scatter plot is, okay, I plot the data, independent and dependent. This is like, maybe this one is independent and this one is dependent. Okay, so let's say this is my scatter plot. Then I found outliers here. Okay, so this is my outliers. Okay, here's a noisy data. Okay, so this conduct statistical process to conduct the estimation of the relationship that is independent and dependent. Okay, so from the regression, you will know, okay, which variable that is have a relationship and which variable doesn't have any relationship. Okay, so for any data that doesn't have any relationship with the dependent variable, okay, we remove it. Okay, we remove it. Okay, when we do the regression, okay, let's say when we do the regression, okay, I get a fitted line here like this. So maybe this one is y is equal to, okay, 453 minus 0.156x, let's say. Okay, so I got it. This is 453. Okay, so this is my regression line. Okay, then I check one by one. Okay, y and x. Okay, so this one I got 0.156 and I check the p-value whether it is significant to y or not. Okay, if it is not significant, I can carry on with the analysis. If it is not significant, if it is significant, I can carry on. But if it is not significant, which means that I can just ignore it. Okay, and let's say I have another one. This one 0.156 x1, okay, plus 0.3 x2. So I have this one is x1, this one is x2. Okay, so we check which one is significant with y. So later we find out that only x2 is significant. Y and x2, okay, are significant. Y and X2 are significant. So which means that X1 is not significant, which is the noisy. So we remove it. Okay, but in regression, okay, there's many ways for you to find the significant or not. Okay, then you test Y, S1, S2. Then you test Y, S1, S2. Okay, first you try Y and X1. Second, you try Y and X2. Then second, you try Y, X1, and X2. Find whether it's significant or not. Then you try Y, X1, X2, and also the interaction, X1 times X2. Yes, you can do it. Then see which one. Okay, sometimes, okay, Y and S1 is not significant. Y and S2 is significant. But Y, S1 and S2, this one is significant. X1 is not significant. Okay, but later, when you run all this X1, X2, X1, and X2 interaction, all of it are significant. So which means that, okay, the noisy is not because it's S1. Okay, it's not because it's S1, because you have to do the interaction. It has the, we call it as conditional independence. Okay, this one we call it as conditional independence. Sorry, conditional independence. Conditional significance. Okay, conditional significance. Okay, so we have like many ways, okay, to overcome with noisy. Okay, next is clustering. Okay, what is clustering? Okay, clustering is a technique involves grouping data with similarities together to form a cluster in order to ensure the organization. Okay, the data that cannot fit in this cluster will be the outlier and clean out. Okay, like I said, clustering is like, okay, let's say you have 10 factors. Okay, you have 10 factors. Let's say gender, preference, height, weight. Let's say you have 10 factors. A lot, height, blood type. Okay, so you want to find which one is the most significant. You do a clustering technique. Okay, then we see that if, okay, the data is not fit into the cluster, so we see that the cluster is only 3, which is height, weight, and blood type. So gender and the preference is clean out. We rule out from our analysis. Okay, then after we rule out the analysis, we run again using all these 3 variables only. Okay, so this is the type, this is the ways to, some of the ways to overcome noisy data or outlier. Okay, I'm very sleepy. Okay, another last method is the removal of redundant data. Okay, if you key in your data using the SQL, okay, it's almost impossible to get redundant or duplicated data. Okay, so usually duplicated data is usually the unwanted one. Okay, so when we extract from different source, okay, there will be duplication of data. So we need to remove it. Okay, we need to remove it. Okay, there's many tools in Excel. Even in Excel, we can spot the data redundant. Okay, so if we found it, we just remove it. Okay, because it will distort our analysis. Okay, any question? Oh, how many clusters can be formed during the analysis? Okay, actually, it depends. Okay, it depends. Okay, when you use the, okay, let me show you here. Okay, so this is like cluster analysis. Okay, so when you use the SPSS or anything, okay, you can see that, okay, there's a cluster here. Okay, there's a cluster here. Okay, and like this, we see that there's a cluster here. So any data that is not in the cluster, we can just remove it. Okay, and How many cluster? Okay, it depends. Okay, it depends. Okay, so usually this is classification where we don't put any number of the clustering. So we just classify this and this. But for clustering, okay, so we decide, okay, what is it? Okay, so like in your in clustering, okay, so you decide it, you set it. Okay, sometimes it depends. You can set it or you cannot set it. Okay, like in SPSS, there's a graph for this. Okay, there's a graph for it that will show you that actually you only need 3 clusters. So then you see from the graphical presentation, like this is already summarized that it has 2 clusters. Okay, you can see it from the graph. Oh, sorry. That. I don't know how to remove this. This using iPad. I mean, okay, so this is the cluster. Okay, so it depends on how you, okay, if it is beyond the cluster, you can just remove it. Okay, this is a cluster analysis. Wait, let me show you the cluster analysis in SPSS. Okay, this like in SPSS. Okay, like this. So you see here, there's 2 clusters, the green and the red one. So this is considered as outliers. Okay, this one is 2-step cluster. Okay, so this one is, you see that here, cluster 1, cluster 2, cluster 3, and outside of it is unknown, is outliers, noisy. Okay, so what else? Okay, this is another one. 1, 2, and all this is called outliers. Okay, wait. I stop to unshare. Oh, you cannot see it. If the cluster size is small, how do we know we treat them correctly? This data could be a cluster or it could be outliers to form a cluster. Okay, so usually for the outliers, okay, it's not that contain much, usually like 1, 2, it depends on how many data that you have. Okay. How to get to top share? Oh, okay. Okay, so how do we know we treat them correctly? Okay, usually we use analysis for this. Okay, we use software for this. Okay, usually we will use software for this. So it depends on how, okay, let's say that you can see the cluster. So outside of it, okay, you see that, or maybe the outliers can consider as also as a cluster, right? Like you claim. Okay. Okay, usually first we see whether it's significant or not. Okay, usually if you form in a one cluster, you'll be significant to your analysis. Okay, so if the outliers here usually is not significant to your analysis, so that one is not as considered as cluster outliers to form a cluster. Like it's a outliers cluster, yes. Okay, but it is not significant to analysis, so we can just remove it. Okay, so you must check it is significant or not. Okay, from the usually we use confidence levels, we use a p-value. Okay. Okay, next is data integration. Okay, as discussed earlier, okay, data integration, okay, is bring together of data, okay, bring together of data from different sources after extraction. So like my example from CSV format, okay, you want to transport into SPSS. Okay, in SPSS, usually we use SAV. Okay, so one data file is created to store the data that is not to be integrated. Okay, the data comes from multiple sources, okay, such as database, okay, data cubes, and also flat file. Okay, but there will be, during the integration, okay, there will be few issues that addressed by the data integration. Okay, so first one is when you have a schema integration. Okay, so okay, one of the problems faced during the integration process of data is the entity identification problem. Okay, so when the metadata, okay, extracted from different sources, okay, is not compatible with each other. Okay, so it might be because of the naming of the primary keys. Okay, so let's say that, okay, we have two data sets from source Y and Z. So student ID in Y may be represented using like this, STUD underscore ID. Okay, but in dataset Z, it represents as S underscore ID. So you have a different naming of the ID value to mean the same. It will cause an integration issue. Okay, data integration ensures that such issues are easily detected and deal with so that the coherent data sources can allow for the integration of data. Okay, so when you do the schema integration, so you have to make sure, okay, you name the primary keys in the same way because it is case sensitive. So you must make sure that like the capital or if you use any other symbol, okay, it must be standardized. Okay, redundant data. Okay, integration data from multiple sources, of course, you can catch duplication or duplication in the occurrence of tuples. Okay, so redundant data in the data set leads to inconsistency. Okay, integration of data from multiple sources, okay, you can have a duplication. So if you have the redundant of data, okay, it will lead to inconsistency. When you do the analysis, the outcome will be, okay, will be not inaccurate. Okay, so we have a correlational analysis during the data integration to ensure that the occurrence of data redundancy is detected and reduced. Okay, so usually to overcome redundant of data, okay, we have like correlational analysis. Usually we have like a special analysis statistic that you can find is there any redundant data. Okay, so other than that, you can use the, you have to do the integration carefully from one source to another source, okay, to eliminate data redundancies and inconsistencies. Okay, so data mining speed is increased and the quality of data is also improved without the redundant data. Okay, if you have a duplicated data, okay, let's say that, okay, you have 350 data. Okay, when you do the integration, so you see that you have around 450. So you have around 100 redundant data. It's lagging a bit. It's lagging. Okay, so you have a 450 data. So you see that you have extra 450 data. Okay, so when you have extra, you know that you have a 100 redundant data. So what you have to do is you have to, okay, remove the redundant data. Okay, in SPSS, they can, and SPSS or also in Excel, okay, they can spot out which one is redundant data and you just easily can remove it. Okay, conflicts in the data values. Okay, conflicts in data value usually if the data is not, okay, in the domain, okay, it's not within the domain, or if the data value, okay, let's say, okay, in the example below, okay, the data value from different multiple sources may be different to represent the same data entity. Okay, so let's say we collect a data for temperatures of a body. Okay, so we collect it in Celsius. Okay, but in source B, it collect in Fahrenheit. Okay, so you have to do a thorough investigation, okay, a thorough check, so that if you do any different unit, or if you do any like if the domain, if the data is not inclusive in the domain, you have to repair it manually, okay, or you can, if it is a lot, you can just use software to do it for you. Okay, so proper conversion of the data values to one standard value will ensure consistency in the data and reduce conflict in the data values. Okay, usually if you use software and set the domain and you do the integration, usually it will not cause any noise, that will not cause any redundant, and it will not cause any conflicts. Okay, but if, okay, you use some kind of like, if you do it manually and you key in, then you integrate it, usually it will, like human mistake, you have integrate, there's issue in integration and redundant, and also other conflicts like the unit conversion, or the unit, the value, the tuple that you key in is beyond the domain. Okay, this one is the data reduction. Okay, data reduction. Okay, during the extraction process, okay, a lot of data collect from different sources. So, okay, the data may be too large for the business organization to conduct analysis, or maybe it is time-consuming process. So we do data reduction, okay, in pre-processing to ensure that the data is limited to information that is very important and critical to business organization. Okay, so data reduction can be, okay, whether you can use reduce the dimension, or whether you can use the observation. Okay, so data reduction is a task in data pre-processing that ensures that the data set is limited of to information that is very important and critical to business organization. Okay, it's also conducted to extract suitable data subsets of data attributes from a large number of attributes. Like I said, you can choose attributes that is related to your study only. Okay, let's say you have 5 factors for house price. Okay, like I said, okay, you can just select any factors that is related to your study, so you reduce it. Okay, so when you reduce the attribute, we call it as dimensional reduction. The number of attribute and tuple also reduced by the data reduction process. Okay, so if there is an increase in the storage efficiency with a reduction in cost, time, and money spent in the data mining process, okay, the process usually complex and involves several steps. Okay, so if you reduce, okay, number of attributes, okay, in your data, okay, you only select any data, okay, that is related to your study. Okay, so if you use, because some of the attribute is not useless for your, is considered as useless for your analysis. So okay, rather than you use all of the attribute, you only use the related one. Okay, and if you use the analysis for all of it, it will time consuming to do the analysis. Okay, time consuming, and also it'll be very slow. Okay, and it will be costly. Okay, so we have a few process, okay, to handle the data reduction. Okay, first is data numerosity reduction. Okay, this is a technique of data reduction that involves breaking down the volumes of data into smaller form of the data. Okay, they bring out the same meaning as the original data. Okay, processing of the large data set is time consuming and expensive, so numerosity reduction can be conducted using data sampling, data clustering, or histogram. Okay, I never use histogram, but I use sampling or data clustering. Okay, so let's say I want to do a COVID, like my previous example, I want to do a COVID research. Okay, so if I want to do a COVID research, I don't have to get the whole population in Malaysia, okay, for my study. So I only select sample. Okay, I only select sample that carry out with my analysis. Okay, so how do I know how much sample is enough to cover the whole Malaysia? Okay, there's a special, we call it, in statistics, we call it a sampling technique. Okay, so we know that how is the what is the minimum sampling, okay, that is required, okay, for, let's say I put like the population maybe 1 million, okay, I use there's many sampling technique, okay, like ratio sampling technique, random sample technique, there's a lot, okay, there's a lot. I am not teaching you statistics now, okay, but using sampling technique, you know what is the minimum value, okay, that is going to carry out in your analysis, but it is enough to cover the whole population. Okay, so that is data numeracy reduction by using sampling. Okay, other than that is clustering. Okay, so I show you the example previously. So we know that if, okay, we have this, like if we have like 3 clusters, that everything is together. So you find the outliers that is not significant to your study, so you remove it. Okay, you remove it. So you have reduced the data. Okay, next is data cube aggregation. Okay, data cube aggregation are multi-dimensional arrays, okay, that store data after conducting data organization. Okay, I have to show yesterday about the data cube. Okay, the data reduction technique ensure that data is reduced using the online analytical process, online analytic processing operation or lab, okay, by using slice up, roll out, drill down. Okay, data queue aggregation use the smallest value of data necessary to the problem. Okay, so let's say, okay, you when you do the data queue aggregation, okay, data queue they put is a multi-dimensional arrays. Okay, so okay, we use OLAP, okay, to find any data that is crossing our interest only. Okay, let's say I want to do the house price, to find the analysis of house price versus salary, right? Okay, from a data cube. It's a bit lagging. Okay, from a data cube. For the data sampling, what is the best practice of the ratio? Sample versus actual data set. Okay, for this, okay, like I said, there's a few technique for the sampling technique. Okay, there's a, okay, you can get a random sample. Okay, usually random sample is just a rule of thumb. Okay, just rule of thumb. Okay, but it must be, but it's also requirement. Your data must be more than 10,000, blah, blah, blah. Okay, it has the requirement for this. Okay, so there's a many formula, okay, for sampling. Okay, this one is Slovin's formula. Okay, this one is 1 plus, okay, this is, okay, so this is respondent sample size over n times n. Okay, this is like this. Yeah. Okay, n is the sample size. N is the population size. 1 plus n is the sample size. E is the acceptable sampling error. Okay, usually we use 95% confidence level, and proportion will be 0.5. Okay, so this is like the same, using Sloven's formula, but actually you have a confidence interval, so many other formula. Okay, like this. Okay, this is a sample size in binomial and hypergeometric. Okay, and this is a sample size using proportion. Okay, and this is a stratified random sampling, total sample size over entire population times population subgroup. Okay, let's say you want to do, maybe you want to do 4 variables. Okay, so the subgroup that you want to do is 4. Okay, so other than that is, this is okay, sample size by using confidence interval. Okay, Z is the confidence interval times P is proportion. This is an acceptable error for the sampling. Okay, so there's many formula for this. Okay, but usually, yeah, they use Sloven's formula is the is the most popular. Okay, to use it. N over 1 plus n, and E is the error. Okay, and okay, this is also another one. Okay, sampling size. okay, that you use the T table. Okay, so this is a T table times with the S is the standard deviation for samples over R is the relative sample error, okay, times with the sample mean. Okay, so there's so many other like formula for the sampling technique. Okay, this is a cluster sample. Also, you also have it. Okay, there's also cluster sample. Okay, so there's so like I said, there's many ways for you. Okay, is there one sampling technique that is considered the best of all techniques? Then okay, so if you if what the statistics, but I cannot see. Okay, if you are using social science research, okay, I recommend you to use this one, the systematic random sampling, okay, or systematic random sampling. Okay, there's a formula for that. You can use the Slovin's formula. Okay, so if let's say you use the scientific, like science research, okay, if you use science research, better you use the confidence interval sampling. Okay, this is from my research. It's like what I read in the paper in the academic research. That's how I found out. Okay, so if you do like mathematics or statistics, okay, usually we use the sometimes we just use random sample, just use rule of thumb. Okay, sometimes we use the cluster sample. Okay, so it depends on your study objective, to be honest. Okay, so how do we know what is the correct sampling technique? Okay, so what I did was I read the past paper. Okay, I read the past paper. Okay, and I use that sampling technique. Okay, and I compare. Okay, usually for me, because I want like I go for the most conservative part. Okay, so I think the most conservative part would use the higher sampling technique, so that one is my preference. Okay, yeah. Okay, any other question? Okay. Okay, so yeah, for some of the sampling technique, okay, they just use the ratio. Yeah, they use the ratio, but there's a formula for it. Okay, there's a formula for it. Yeah, I'm not teaching you statistic. If I'm teaching you statistic, we can dig further on that. Okay, systematic random sampling, there will be stratified random sampling, or sometimes they even like have a sampling that sequence. So we arrange it, then we choose every fifth of every fourth, something like that. Okay. Okay. Next is dimensionality reduction. Okay. During the data mining process, it's not all data attributes are required. Okay. I think it's like repetitive in the above part. Okay. This data reduction technique reduce some parts of the data or the entire data depend on the needs of the organization or whether it's easy to retrieve the data. Okay, dimensionality reduction techniques such as decision tree reduction, forward selection, backward elimination, or combination of the forward selection and backward elimination are used to get the most suitable attribute subset that we use during the data analysis problem. Okay, so for the dimensional reduction, I know you not understand it, what they talk about. Okay, what the notes explain is actually if you have a data with a lot of attribute, okay, you use regression or cluster or classification. Okay, so if you use the regression, okay, if you use the regression, you can use like decision tree induction, forward selection, backward elimination, combination, and all that. Like I said to you, okay, first you try Y and X1, then you try Y1 and X1, then X2. Okay, then you try Y1, X1, X1, X2, sorry, Y1 and X2. Then after that, we try Y1 and not Y1, Y is only one, right? Okay, Y and X1 and X2, and also interaction of X1 and X2. Okay, so you see which one is significant. Okay, so what does it mean by tree? 3 induction, forward selection, backward elimination. Okay, actually it is steps in regression. Okay, 3, which means that, okay, we put all of this like this, then we select which one is significant, then we keep it. Okay, forward selection means, okay, we start one by one. First, second, third, fourth. Okay, forward selection. Then we see which one. Okay, we see that this is the best model, then we go with this. Okay, we try one by one. For 3, we put everything together at 1, then we eliminate. Backward elimination means we start with this first. This is number 1, number 2, 3, and 4. Okay, then after that we come up with solution. Then we see that this is the best method, so we keep it. Okay, or combination of the forward and backward. Okay, combination of forward backward. Okay, we try put everything first, then we run again. We put one by one. Okay, our combination means we do stepwise. So which means that we try this first, number 1. Okay, then we try this, number 2, this is number 4, this is number 4. Okay, then we find the best method. Okay, usually you don't have to test all. Okay, you can just use, usually I like this one, backward elimination. Okay, backward elimination, so it means that we put everything first. Okay, then they reduce one by one. Or forward also good. Okay, which means that we start with 1, all variable, then 2, second variable, third variable, fourth variable, then find the best, what is the best model for your analysis. Okay, so this one is only if you have 1 independent and 2, sorry, 1 dependent and 2 independent. But if you have like 50 variables, okay, it will take time to do it. Yeah, statistic will take time to do it. Let's say you have 50 variables, so how many combination that you are going to do? So you have to wait like almost a whole day just to complete your model selection. Yes. Okay, that one is only to reduce the dimensional. It's not including to remove the outlier and all that. Okay, and data compression. Okay, this data technique ensures that large volumes of data are compressed to reduce the amount of space used to save the original data. The large data set is tedious to work around. Okay, consume too much space and spend a lot of time and money on them. Okay, it takes place when the number of bytes used in the data storage. Okay, so there are 2 types of data compression, lossy and the lossy and lossless compression. Okay, lossy compression makes the data quality of the compressed to be changed, while the lossless compression ensures that the data compressed will be similar to the original data. Okay, it's like similar like how you compress your all your data. Okay, you zip it or you unzip it. Usually, okay, if you compress it, I like to preserve in RAR compared to zip. Okay, sometimes zip will change the nature of the data. Okay, but I think now the memory is not as memory issue is not as complex as previously. So if you don't have memory, we just you know, we have data warehouse, we have like HDD, we have a lot of like online yeah, online database, okay, that we can get the extra memory. Okay, last is data transformation and data discretization. Okay, so this is also a data pre-processing, okay, after data cleaning. Okay, like I said, you transform the data. Okay, you transform the data by combining structured and unstructured data. Okay, so we have a few techniques to do for the data transformation. Okay, the first one is normalization. Okay, what is normalization? Okay, so data transformation that involves scaling the values of data in a data to a range that has been. There are 3 types of normalization. We have minimum, maximum normalization, z-score normalization, and decimal scaling normalization. Okay, minimum, maximum normalization is not that popular because I think statistician doesn't like it, but we like it, Z-score normalization. If our data is too large, okay, we can also use natural logarithm, or we can use Z-score normalization. Okay, we assume that mean is Z-score normalization. We assume that mean is equal to 0 and standard deviation or variance is equal to 1. So we do the Z-score normalization. Okay, but this one is only for numerical data, not for the nominal or ordinal. Okay, so decimal scaling normalization. Okay, decimal scaling normalization usually, okay, if you have a data with many decimal, okay, like I said, you can use natural logarithm, or you use reciprocal, or you use decimal scaling normalization. Okay, usually we don't do it in using the, we don't use it manually. We do it by using software. Okay, like in Excel, you can choose what transformation that you want to use. Okay, you just click it, then they transform it for you. Okay, but somehow you don't know what transformation that you have to do. If your data is fine, if you run your analysis and it looks your output is already correct and convincing, you don't have to do anything. You don't have to do anything. Just use the raw data. If let's say your data, okay, when you run it, the output is hard to, maybe the value is too small or the value is too big for you to interpret, then we use the transformation. Okay, we use the transformation, especially if you are in a bioinformatic industry. Okay, so they use a lot of the bioinformatic, they use a lot of like genetics data and all that. So usually they have like many zero, okay, they have many outliers and all that. So yes, they have to do normalization, then a lot of things to do. Okay, next is discretization. Okay, this is a data transformation technique, okay, that ensures data is large and continuous, transformed into a small attribute. Okay, during the data mining process, most of the data is continuous, but the frameworks available are not able to handle this type of data. Okay, so discretization, okay, into a set of, okay, so usually, okay, discretization of data is also a transformation. Okay, so big data, large data, okay, and continuous, okay, we transform into a small set of attributes. Let's say that, like I said, that if let's say your house price, okay, is all 500,000, 200,000, and suddenly you have a data that is like 10 million. Okay, 10 million, and another one is like maybe 100,000. Okay, so you see that it is very hard for us to do a data analysis using a big number. Okay, using a big number, so we transform it, okay, to make it small. Usually we use logarithm, natural logarithm. Okay, other than that, you use data smoothing, okay, to remove noisy values from data set. Okay, using that. And okay, for any missing value, okay, for any missing value, okay, we can use such as median, mean, okay, to replace the missing value if you deal with small set of data. If your data is big, you can just ignore or eliminate the data from your data set. Okay, and lastly is attribute construction and selection. Okay, so we ensure that new data attributes created on existing data and select the data attribute that will be agreed on to analyze. So it makes the data mining process efficient and simplifies the data was originally mined. Okay, so after the data cleaning, okay, you remove the outlier, okay, and this one is like another repeating point. Okay, you remove the attribute. Okay, you select the attribute after you know that which one of attribute is significant to your study. Okay, it's similar like dimensional reduction.